Okay, so the arrival of clients are created and we have changed the picture of the entity that we are going to see in the process of this system. Now, what is the next module that I am going to introduce? Is the process. Now, a process module, when you create a process module, it is going to define a basic queue system with resources. Okay? So what is a process? It is basically an activity in which the entities sees a resource and delay this resource for an amount of time, then they release this resource. Okay? So they seize a resource, basically. They hold a resource. For example, whenever a client arrives and the time for the service starts, the client holds and seizes the teller. Okay. So seizing means what? Yakasına yapışmak. Okay. Seize him. Okay. Seize the teller and ask him to do your job. Then this job is going to delay the teller for a while. Okay, there will be a delay for the teller. While that delay amount of time, the server, the teller is going to serve to you. Then when your job is done, when your process is done, you are going to release the teller. But when you release the teller is going to be seized by the next person in the queue. Okay? So in a queuing system, the clients, they come and they seize the resource, which is the teller, and then they delay him for a while, then they release him. Okay? For the next client to seize. Okay? So this is the case. So when you create a process, this process is basically the process in our queue. And let's double click on this process module. And by the way, you see, let me erase this process again. Let me introduce again once more. When I introduce a process module to the flowchart view, as you can see, right now they are not connected. Okay, they are not connected. However, if you click on the create module, and while the create module is selected, and now if you introduce a process module, they are going to be automatically connected, which means created modules, the created entities will move to this process. Okay? Now, you may ask this, if they are not connected, how am I supposed to connect them? Now, you see here, so this picture is getting problematic for me because of, okay, so, yes, there is a connection tool here if you see, connect, okay? So that is the connect tool. This connect tool, when you click on that, will help you to connect the create module to the process module, and this is going to assume as if the created entities are going to move toward this process. So the women pictures are going to move from here to here. Okay? Now when you click on the connect item and press delete, you can erase it again and you can always connect it again. Okay? That's the case. So we have the process module here and I double click on the process module. Okay? Now, the name of the process will be what? Let's just say service. Okay, service. So let's just say it is teller service. Let's imagine this is a bank, right? This is bank. So this is the teller service. And what type of process is that? Is it a standard or a submodel? Now, if you choose the submodel, this means this process is going to be a submodel. Okay, let me show you that. It's a submodel, and when you click on that process, you are, when you right click on that and you say edit submodel, it is going to show you another page, and in the navigation, you are going to create a submodel under the whole model. So you see the hierarchy here creates a submodel, and by this system, you can create models, submodels in the models, and sub-submodels in the submodels, and you can create a very, very complex structure of models like that, and without complicating the view, without complicating the overall view. However, we are not going to use that at all. So I right-click on the submodel and I say close submodel, and when I double-click on the process, I choose again a standard process. Now, in this standard process, every client that I create, they seize the teller, they delay the teller for a while, then they release them. Okay? So what is the difference between seize, delay, release and the other options? So delay means there is no resource. There is no teller, which means a self-service system. If you just delay, apply delay, if the logic is delay, this means the teller is going to enter the process and just going to wait for a activity time. Then they are going to leave. They are not going to need any resource for this delay. Okay? Now, if you choose seize delay, then the teller is going to seize one of the resources. Then they are going to spend some time for the activity with that resource, but they are not going to release that resource, and they are going to bring that resource within themselves to other processes. So they are going to take the resource from that process to move that resource to the other process. Imagine this. I mean, you are taking the teller and he performs your task, but in order to move to the next process, you are also taking the teller with yourself. Okay, you are not releasing him. So the teller is also going to come with you. So the teller, the resource is going to be attached to this entity itself. If you choose seize, delay, release, now you are going to seize the teller and delay him for a while. And when your task is done in that process, you are going to release him, but this teller is going to be seized by the next client in the queue. And if you choose delay release, this means you already have a resource with yourselves when you enter in that process, and you are going to delay that resource. Then after the job is done, you are going to release that resource. So, for example, if you choose seize delay in a process, then in another future process, you need to choose delay release, right? Because, I mean, at some point, you need to release the resource. You cannot take that resource outside the system with yourself. So that resource is a part of the system. I hope you understood the differences between all of them. Again, you can ask these questions, okay? So what is action? And I don't know if you can see. Okay, so you see type of processing that will occur, so and so forth. So it explains only action here, but you can check the differences between those 4 things from the textbook, okay? So this time we are going to seize the resource, delay the resource for a while, and release him afterwards, okay? And now, who is the resource which we are going to seize? We need to add a resource here, okay? So what we are going to use as a resource? And I say add. So I add a resource. What is the name of this resource? Is teller. So a teller here is a resource. And how many do I seize? So if I want in a bank, if I want my job done by a teller, so I need to seize only one teller. One teller is enough. So every client is going to seize and release only one teller. Okay? So every client is going to be involved with only one teller. And so, by the way, this does not mean that there is only a single teller here, okay? The number of tellers in the system, I am going to change from that somewhere else. So this one here means that every client is going to utilize a single teller, okay? If you choose, for example, 2 here, if you double click on that, and if you choose 2 here, this means the client seizes 2 tellers. I mean, in order to perform the task of that client, we need 2 tellers, not just one of them. Okay? So at this point, we know that every teller can check, do the job of every client. So we choose one. Okay. And what is the delay type? Remember in the question, we have the service time to be exponentially distributed with rate parameter 0.50, which means the average service time is 2 minutes for the exponential distribution. So we are going to write delay type is, do you see an exponential here? No, right? You do not see it. So I say expression. The delay type is expression. In minutes, and at this point, I'm not going to explain this, but you can always choose it by value added default, and I'm not going to explain the priority here. Again, at this point, you can simply choose medium. Okay, there will be time for explaining those. And here at the expression, I write expo. What is the average time? It is 2 minutes, right? The average service time is 2 minutes. And because it says minutes here, it will understand it as minutes. Actually, it is going to understand that as minutes automatically because in the run, the base time unit is changed to minutes. However, if you change this to hours, it is going to understand it as hours. Okay? So here we have minutes and I say, okay, now my process has been defined. So there is a queue here. And in this queue, every client that will enter the queue is going to see the teller. And then they are going to, when they release the teller, they are going to leave the system. Okay. Now from the basic process panel, you see I have created a process. And because there is a resource in that process, automatically a queue will be created. If there was no resource, if this process was a self-service queue, in that case, queue wouldn't be created. Okay. Now you see this is the queue animation. Okay. This line here, T-shaped, horizontal T-shaped line is the animation for our queue. We are going to see the behavior of the queue on this animation. Okay. Now we have this process created and I want to show you that in the spreadsheet view, because I have created a resource, in the resource spreadsheet, as you can see, there is a resource automatically created. Okay. So we have a resource, which is teller. And I want to explain everything in this row. So I double click on this row and open the dialog box. So I have a teller, right? How many tellers do I have in the system is I'm going to write in the capacity. Okay. So if in my system, if there were in this bank, if 4 tellers are working, 4 parallel tellers are working. If we have 4 parallel servers, then we write 4 here. So this is the point where we change the capacity of the tellers. Okay. But you know, because this is an MM1 system, I only have a single teller. Okay. And we can change the capacity changes based on a fixed capacity. If I choose fixed capacity, then this means throughout the whole simulation, throughout the whole day, there will always be 1 teller. Okay, it says fixed capacity. But if I say based on schedule, then I can determine the number of clients working in that system. Number of servers working in that system, changing based on a schedule. For example, I can say that in the first 2 hours, 2 clients will work. The next 3 hours, 3 clients will work. And the next 2 hours, 4 clients will work. Okay. I can change the number of clients based on a schedule, which I am going to explain later, not in this example. So we have a fixed capacity throughout the whole simulation. There will be only 1 client, 1 server, 1 teller in the system. Okay. And the costs of busy time and idle time of the tellers can be written here. So you can calculate the cost of the system based on the resources that you use. And the rest, I'm not going to explain at the moment. Okay. So this is the spreadsheet for the resources where I change the parameters on resources. And because I have created a process with a queue, actually that queue is also going to be created in the spreadsheet module of the queue system. Okay. Queue spreadsheet module. So you see, I have a queue here, the teller service queue, and the discipline of this queue is first in, first out. which means the entities are going to be served in the order that they arrive. But I could have changed that. I could have changed this to last in first out as well. For example, this means the last member in the queue behind the queue is going to enter the first. Okay, so I can create the queue with a different queue discipline, and this is the point where I change the queue discipline. Okay, and I can change again with lowest attribute value or highest attribute value, but I'm going to explain those later. Okay, not now. This is too early for you to understand these two things. Okay, so first in, first out is my queue discipline, but I know that I can change the queue discipline from this queue spreadsheet view. Okay, because I have created a queue, because I have introduced a resource in that process, automatically a queue has been created for that process, which you can see here. Okay, now I am coming to the last point. Okay, the last point. I am going to, so when the process ends for a client, the client is going to leave the system, right? The client is going to leave the system, go back to the calling population. And for that, I click on the process, then I click on the dispose, and the dispose module, so let's change it to disposal of clients. The clients that are created by this module are going to be disposed, and they are going to be removed outside to the outside of the system. Okay, they are going to remove from our simulation. So when their service is done, they are going to leave the system. So this is our bank. So these three modules, they have created our bank in which a happy teller is working, okay, for 7 hours a day, and the inter-arrival times and the service times are introduced according to their statistical distributions. Okay, now we have created this system, and now I want to run the simulation of this system. Okay, now from run here, if I click on this go, then the simulation is going to be started to run. And right now, you know, the maximum number of clients is what? Infinite, right? So if I click on this, so you see, it is running very fast. The simulation is running very fast. So let's slow it down. Okay, let's slow it down. So here we have a scroll where we can slow down the simulation process and make it faster. And we see the animation button here, which is also here, as you can see. Now let me zoom in. So let's see. So right now, up to this point, the simulation has run for approximately 2,300 minutes. Okay, 2,300 minutes. So it is very fast. The clients are arriving according to this process. Okay, and right now, there are seven, as you can see. Now it becomes 8, it becomes 9, 10, 11. These are the numbers in queue, and there is one client in the service as well. So when you see 15 here, 14 of them are waiting in the queue, and one of them is getting service. Now, because my animation is limited, obviously, you will not be able to see all of the women here, okay? So these are the women pictures that I have mentioned, okay? But you see, when we have 5 clients in the system, you see 4 in the queue and 1 in the service, okay? 1 in the service. And whenever a client's job is done, they are going to be disposed outside the system. Okay, so this is my animation, but this simulation is not going to stop at all. Okay, it is going to continue like this. Because I haven't defined any stopping criterion. I have said that I can create as many clients as I want. Okay, there is no limitation for that. And let's make it faster. Now, at the fastest rate, you see how the minutes are increasing, okay? 8,000, 9,000, 10,000 minutes. Simulation is a very fast procedure, okay? So you can simulate the system and observe the length of the queue like this. Now, let's go back. Let's make it slow down. And now I am going to pause it. So when you click on pause, it is paused. So let me make it faster again. So I am going to, so when the queue, okay, I'm going to pause it. So you see we have right now 9,000, up to this point, 9,139 clients have created, and 7 of them are right now in the system. 1 of them is getting a service, and the other 6 of them are waiting in the queue. And 9,132 clients have already left the system by taking a service. Okay, so they are disposed. So you see the difference between the number of created and the number of disposed. It is 7, right? It is exactly the number of clients in the system. My friends, if you have taken a manufacturing course, you have learned the term work in process, right? So 7 here is the work in process. The total number of clients in the system right now is called the work in process. Okay, work in process. The total number of clients in the system is called the work in process. This term is used for inventory management actually, but in simulation as well, in Arena, we call this work in process. So right now, these 7 are waiting in the queue. They are the work in process. Okay, the work in process size is 7. Okay, now I am going to continue my simulation. Now I am going to pause it again, and I'm going to stop it. Now when you say stop, everything will be gone. So we are going to go back to beginning without getting any report. Now, if I want to get a report about this system, I click on run and I click on setup. And from the setup, I change the replication parameters. Now, right now, I say that I am going to replicate this simulation for only once. Okay, the number of replications will only be 1. Okay, now, this start date and time is not important, but if you want to simulate a real system, for example, you can say that this simulation is going to start tomorrow at 7 a.m. Okay? If you tell this, I mean, this is going to give you realistic time values. Okay? Now, we have warm-up period. I'm going to explain this warm-up period to you. Now, when we run this simulation, my friends, remember now, the system is going to start with empty state, right? So in the beginning, there will be no customers, 0 customers. So let's just say LT here is the number of customers in the system, number of clients in the system at time T, and here we have T on the horizontal, time over the horizontal axis. So what I am going to see is this, a shape like this. So in the beginning, there will be 0 clients, and the number of clients are going to increase. Okay, they are going to increase and decrease. And at some point, they are going to oscillate around a certain value like this. Okay, so they are going to oscillate around a certain value. This means the system is going to reach a steady state when it reaches here. So, my friends, up to this point, the system is in the warm-up period. Why? Because the system has not reached its steady state. Okay? Now, if I calculate the average number of clients, if I just look at the statistics obtained in the steady state, then the average number of clients is going to be equal to this blue line. Okay? However, if I include the warm-up period as well, in that case, the average number of clients in the system for T amounts of time is going to be less. Why? Because in the warm-up period, the number of clients in the system has not reached to a steady state. Okay? So, actually this is creating me biased results. Okay? Wrong results. So I need to remove the effects of the bias, the effects of the warm-up period. So I need to cut off, at some point, I need to cut off the initial values up to a certain time, and I am going to estimate my average length of the queue by looking at the steady state part of the simulation. So I need to define the warm-up period when I am going to cut off the warm-up period. So this is here in Arena, here in Arena, the warm-up period I can define as, for example, we should not include the first 60 minutes on a replication, and they are not going to be counted in these statistics. So the first 60 minutes of observation is going to be counted as the warm-up period, and to prevent for them to create biased results in our statistical estimates, we are going to remove every information coming from the warm-up period. We are going to estimate our statistics based on only the steady state results, okay? And here the replication length is going to be 7 hours. It is just going to be 7 hours because this bank system is going to work for 7 hours a day, right? And the number of hours per day can be 24, but you can also change it to 7 as well. So each 7 hours is going to be counted as a new day, okay? So if you say 7 hours, there are 7 hours per day, then each 7 hours of the simulation is going to be counted as a new day, okay? And the base time unit is minutes. So if you write a mathematical expression for a time measurement, then this expression is going to assume the unit of this time measurement as minutes. And I do not need to write a terminating condition here because the replication length is 7, okay? And there is a single replication here. There is a single replication here, 1, okay? So I think I have shown you how you are going to terminate the simulation. Now let's check it. Let's run the simulation at the slowest rate. Okay, you see that has been 9 minutes so far. Remember now, in 7 hours, the simulation is going to terminate. So let's see how many customers we are going to observe in the system. Okay, how many customers we are going to observe in the system. Let's make it faster. Now you see when the time comes to 420, it is going to stop and says, would you like to see the simulation results? So this is a 1-day simulation of this system. 100, so let's just say no at this point. Okay, I'm going to show you the results later. The number of clients that have arrived is 121. And right now, there is nobody in the system because at 420 minutes, the last client has left the system as well. Okay. And at 100, so there are 122 disposals. I am sorry, my friend. There is one teller, one client here, I guess. So we have 121 creations and 122 disposals. So we have this simulation for 420 minutes. Okay. Now, in the statistics that I get, the first 60 minutes are not going to be included. Only the last 360 minutes are included in the simulation results to reach to the steady state. And I have explained the run tools here. And we have the simulation clock here. So this is called the simulation clock. Now let me start the simulation again at the fastest, slowest rate. Okay. So I am sorry. Okay, the slowest rate. At the slowest rate, I can see the simulation again. So you can check the simulation clock from here. Okay. And we have the number of, we have the entities moving around. Okay. Okay. Now, let's just say I want to see a plot diagram. I want to see a plot diagram of the number of clients in the system. Okay. So in these 420 minutes, I want to see, so I stop my simulation, and I want to see the plot diagram of how the clients are going to change, number of clients in the system are going to change. Okay. So in order to do that, so I need to So there is a problem right now. Let me start the simulation once again and stop it. Okay, so the animate toolbar is activated here. I can see the animate toolbar here. So in this animated toolbar, we have a plot object here. Take this plot object, click on that, and it says you can draw a plot diagram of any value that you like. Okay, so what value, for what value you would like to draw a plot, you say add, you click on add, and it creates a series of a plot diagram, and I need to name the series in the first place. Okay, so it is going to be the number of clients in the system at time t. Okay, and I need to define the number of clients in the system at time t as an expression here. Now, my friends, this part will definitely require an expression builder. Okay, so you click on it and you choose build expression. Now let us identify what we need to write. Okay, I want to see the number of clients in the system or in the process. Okay, so I click on the process. Okay, and we have process and number in process here. Okay, so in this process, I want to see the number of clients in the process, which are taking a service and which are waiting in the queue. So number in process, and for which process you would like to create that number in process, it says, I want to create it for the teller service. Okay, for the teller service, I create an expression, and it says, for the teller service dot WIP, this command is going to show the number of people who are in the process. Okay, and it is going to show a plot diagram of it. Now here, as I move to the bottom of this, I can change the color of the plot diagram. Okay, and there is a line type here. This is important. I want to change this line type to stair-shaped functions, because you see the number of clients in the system is going to change with a stair-shaped function. Okay, so the behavior of the function is going to be like this, as you can see, and we have scale of the vertical axis on the left. You can choose it on the right, for example. You can move it here, and you can see by changing these attributes what type of plot diagram you are going to see is shown here. Okay, now these are basically changing the values related to the data series. I have changed the name so I can see it in the legend here. Okay, and I have changed the draw mode to stairs. Okay, now I am going to move on the axis tab. Okay, so I have the axis tab. Now in the axis tab, we have the scale here at maximum and minimum. So at scale, I say that on the left axis, on the x-axis, okay, the time, the minimum value is going to be 0 and the maximum value is going to be 420. So you see, I am going to see my plot diagram from time 0 to minute 420. Okay, my plot diagram is going to show me this from 0 to 420. And if I change the major increment to, for example, 100, then the increments here are going to be at 100 times scale. So if I change it to 50, then I'm going to see the time points at 50 scale. Okay. So I can also change the title. Here. So it is written time already. Okay. But I can change time of the simulation. Okay, time of the simulation, for example. And I need to choose true for the visible, so I will see the time of the simulation as the label of the horizontal axis. And the label of the vertical axis is already written here, so I am not supposed to write it as well. Okay. Now, let's check the y-axis. And my y-axis is showing the number of clients in the system from 0 to 80. So let's just say the scale for the y-axis should be changing from 0 to 50. I would like to see at most 50 clients if I want to observe the plot diagram. Even if the number of clients in the queue exceed 50, I will not see it in the plot diagram. Okay, in the plot diagram, I am just going to see that it has exceeded 50, and when it comes below 50 again, I will see it. And the major increment is going to be, let's just say 25. Okay? So the maximum has not changed because it is auto scale. So maybe I need to change the auto scale to false. Okay, yes. Auto scale maximum, when I change it to false, you see 50 becomes maximum. But if it exceeds 50, then it is going to automatically add another 50. It is going to add another 50 to the plot diagram in that case. So let's just turn them to true again. And there is legend here. And I want to see the legend here. And I want to see the legend as visible, but the location of the legend should be at the top. Okay? Okay, this is going to be my plot diagram. Now, when I click on OK, and there will be as you can see, my pointer has changed. Now, I am going to create a rectangle by pulling towards. And here I will see my plot diagram. Okay, for 420 minutes. So let's just start simulation at the slowest rate. Okay, now I am going to increase the rate of the simulation, speed of the simulation. So I stop. Do you see how the number of clients in the system are changing? So it says, for example, at minute 200, there is only a single client in the system. So the maximum number of clients in the system is observed right now around time 300. Okay, around time 300. So let's continue with our simulation. And when the simulation ends, you will see the whole plot diagram for the number of clients in the system. However, because we have changed the scale, as you can see, we cannot see any values. So let's change the scale again. Let me stop simulation. And you need to stop simulation if you want to change anything in your flowchart. I double click on here again, and from axis here, I choose left value y-axis, and here, from here, the scale is going to be changed to major increment is going to be changed to 3. Okay, so I will see the values at every third client. And let's change the auto scale minimum and auto scale maximum to false, and to understand how it is going to change. So okay, so let's start the simulation again. So do you see my plot diagram now? The same plot diagram, but this time we have a different scale. Because the maximum number of clients in the system is observed to be equal to 12. Okay? So it is still drawing, but 50 is a very large number to observe as an upper limit for the vertical scale. So I'm just going to stop again, and I double click on that. And for the y-axis, I will change this maximum from 50 to 20, so I can see better. Okay? So let's start the simulation again. So this picture for the plot diagram is a lot better. Okay? It is a lot better for the number of customers in the system.